when we are working with transactions, what do I mean by transaction? Continuous stream of data is coming. Here we also talked about partial reading and reading a partially written file. All these things come under generally database system transactions concept. So whenever we are trying to work with a stream of data, how do I ensure transactions and reliability are guaranteed here? Flume uses separate transactions to guarantee delivery from source to the channel and from channel to the sink. Flume will guarantee that it is taking care of delivering the events from source to channel and channel to sink. Now in the example what we have used previously, spooling directory source creates an event for each line in the source. That is one event. Say for example, I have opened a text file and I have written 10 lines. For every line it will identify one event. The source will only mark the file as completed once the transactions encapsulating the delivery of the events to the channel have been successfully committed. What do I mean by successfully committed? All the 10 lines log information has been transmitted to sink. That is the application example we are seeing. As long as I am writing the text line records into the file, I keep on transmitting to the channel. The log information is given to the channel has to post it on to the sink where I have the log file. Until all the record data is transmitted to the sink, I have to keep on posting. So it will not say it is committed until all the transactions are, all the log records are written onto the sink. Similarly, a transaction is used for delivery of events from channel to the sink. So it is trying to take them as two transactions. First transaction from source to post the information onto the channel that these many lines of text has been written. That is one type of transaction. Until all the information is posted onto the channel, it will not issue the commit. Then from channel to the sink, entire log information is to be recorded. Till that it will not give a commit of the second type of transaction. If for some unlikely reason the events could not be logged, suppose it is unable to write from the channel to the sink because that is where we have the log file, the transaction would be rolled back and the events would remain in the channel for later redelivery. So try to understand what it is trying to do. Suppose I have written 10 text lines in the file. So from the source the data has gone to channel that the user has written 10 lines of text. So at the source to channel the transaction is committed. Now from the channel I have to write 10 log records into the log file on the sink. So somewhere after writing 6th record there is a failure for some reason. Do I say the transaction is complete? No, I need to write 4 more records. There is an error at the 6th record. So what it will do? It will roll back the transaction of 10 records and holds them into the channel. The channel will hold the information about all the 10 transactions, and once it finds time or the channel is up, all the issues have been sorted out, it again does the concept of redelivery. All the log information will be redelivered. The channel we were using is a file channel which has the property of being durable. One of the most important properties of transactions is durability. We know acid properties. So the durability is ensured here. Are we ensuring atomicity? Yes, because if there is any error, it is trying to redo them, repost them. Once an event has been written to the channel, it will not be lost even if the agent restarts. So that is how it ensures reliability of the transactions. And overall effect, if you try to work with this, even produced by the source will reach the sink. Every event the source is producing has to reach the sink. Here what is the major caveat? Every event will reach the sink at least once. say for example, in my previous example I told after writing 5 records, there is an error at the 6th record. What the system is trying to do, it will undo all the 5 log records which are successful. Again it will start from record 1. So record 1 has reached the sink how many times? Only once or multiple times? So in my example it is reaching the sink twice, right? You can set the parameter every record should reach at least once or exactly once. There are 2 properties that can be set. If you want every record to go only once, exactly once, then we need to go for a 2-phase commit protocol. If you say it has to reach at least once, then it is only a single phase locking protocol. It is a trade-off how the user wants to have his transaction processing, and the user has complete control over setting the transaction parameters. With at least once semantics, duplicate events will be there. Suppose I am saying every record should reach the sink at least once. So in my example there are chances that record reach the destination multiple times. In such cases duplicate records are to be removed, for which another program of deduplication will be run in order to remove the duplicate records. That is again at the cost of some processing time, right? These are all the preferences of the user or the preferences of the organization, how they want to go for it. I'm okay with higher processing of 2-phase commit protocol, then you set it as exactly once. Every record will reach the sink only once. On the other hand, at least once, you have the chance of getting the duplicates, wherein you need to take care of removing the duplications by running a deduplication process. And whenever we are working with event processing, either you can send every event one after the other, or we can go for a batch processing also, which we call as batching. And for efficiency, Flume tries to process the events in batches for each transaction. Sometimes if it is possible it goes with a batch, otherwise one after the other. And batching helps performance criteria, and this can be done with fsync call. And batch size is determined again, which is again a question, shall I go for 100 records per file or 100 files at a time? These are all the preferences of the user. So if you see, whenever we are working with the spooling, it does batch of 100 lines, but when you are working with Avro, it takes care of 100 events as a batch. So there is a difference. And how do you configure your HDFS sync? This is how you try to define the sync. In case of multiple sync, you need to specify agent1.syncs is equal to sync 1, sync 2, sync 3 and so on. So multiple syncs and multiple sources, multiple channels can be specified using these parameters. And you are specifying the path of this sync also. So you can, if you have multiple syncs, you have to specify the path for each and every sync. And once you set those things, try to restart the agent so that you can see spool to HDFS properties configuration will come into effect. Until you restart the agent, the properties will not be applicable. And what is the concept of partitioning and interceptors? And whenever we are working with large data sets, under MapReduce we know the file will be broken into blocks. When you are working with continuous streams of data in Flume, data is continuous. How do I define the block size? And who will define the block size? Partitioning will be taken care by Flume when continuous stream of data is coming. Right? It will try to put some interceptors based on the timestamp. Say for example, today is, say for example, 12th June. So what it will do? 12th June morning 9 to 12th June, night 9 o'clock is one partition. Once I say that, whatever data is generated within these 12 hours will be considered as one partition. And what are the interceptors? The timestamps which I have set for data collection for this partition will be called as the interceptors. So, the interceptors can be defined in terms of timestamps, date wise, hourly, that is again depending on how fast and how frequently the data is getting generated. So, if you see, this is how we are setting the interceptor. If you see in this, year is fixed, month is fixed, and you are trying to talk about day as the final partitioning parameter, right? If you want in a day, you want to make hourly partitions, you can specify that in the interceptor specification. So, this is how we specify partitions and interceptors. What is the interceptors type we are using here? Timestamp as the interceptor, month, year and hour, or month, year, day likewise. And what are the various file formats it can work? It can work with the sequence files, it can work with the long writables, it can work with byte writables, various types of data types, various types of files it can work. If we do not specify any specific file type, by default it will be a sequence file, and by default it works with bytes writable. This is the default data type. If you do not want to work with bytes writable, you can try to work with long writable, whatever is your choice. So, the default types are sequence file and bytes writable. So, this is how we set various formats of the file. Similarly, I want to work with a compression technique, you need to specify the compression parameter. So, these are the various parameters to be set whenever we are working with a continuous stream of data.